Hey everyone, how's it going? So first of all, who am I? I'm Facundo. I work in the Cosmos SDK as an engineer. I'm also the tech lead at Atom Accelerator DAO. And well, I'm originally from Argentina and I'm living in Andorra right now, so a bit up north. And I'm gonna thank Julian for the slides. Super cool engineer. So I stole my slides from him. So let's get started with what is the Cosmos SDK. So basically, it's a framework that you use to build blockchains. That's like the most basic definition of it. But basically, you can build sovereign blockchains and also blockchains that depend on other blockchains. So in that case, would be the interchain security, in which we're probably going to touch on that later. But you don't have to have your own token or your own security. You're getting your security from other chains. You can do decentralized infrastructure, decentralized finance, decentralized whatever, basically, because you can have from stuff just, I don't know, DEXs, you can have stuff that, I don't know, lending protocols and all that stuff. You can build it with the Cosmos SDK. We like to say it's limitless because we are not limiting the users, the developers with a VM. Usually VMs have very constrained functions, like, I don't know, with Ethereum, you need to use Solidity, and Solidity, it's very constrained in many ways. Here you use Golang right now, for now, and you have like full control over how you make blocks, how your transactions work, what messages you can accept, what messages you can process, and all of that. Then we like also to say that it's plug and play, because you can just use, you can make your own modules, but you can also go to other chains and see what they are using, and then you can borrow some modules if their license allows you, of course. And you have more than 20 modules, and we're being a bit pessimistic here. I think at least you probably have like 40, 50 modules that are well used in many blockchains. We're going to talk more about those later. And also, it's fairly extensible because you have IBC. So with IBC, you can do transactions from your blockchain to other blockchains. You can also use interchain accounts. So basically, from your blockchain, you can control accounts on other blockchains just through an IBC connection. And IBC, we like to think and that it's very secure, hasn't been hacked yet, but it's widely used, and like probably all of the chains built with Cosmos SDK have IBC. Then we have VMs. You have some EVMs, so you can be compatible with Ethereum. You have, I think it's Ethermint, then you have Evmos, you have a bunch of implementations of an EVM. And then, of course, you have CosmWasm. CosmWasm allows you to create contracts with Rust. That's what Neutron uses, for example. And yeah, it allows you to create things on the go and then upload them to the chain permissionless or permissioned. So you, as a developer of a chain, can actually decide if users can upload whatever contract, or that you can allow like a specific set of contracts to run on your chain. Basically, as a chain developer, you can focus only on your chain and just your chain and the functionality of your chain, because everything else, it's been taken care of for you, so it's in the box. And we're going to talk also more about that later. It's the framework of the interchain. So you can see here all these chains. Some of them are very small, some of them are very big, but all of them are using Cosmos SDK. So you have Neutron, of course, Axelar, Stride, Say, Osmosis, Noble, well, of course, the Cosmos Hub, and then you have a bunch of all smaller chains all around it, and they're all interconnected by IBC. And what is interesting is that you can probably do crazy things. I don't know, if you have some tokens in like a very unknown chain, I don't know, asset mantle, I don't know that one, but you can probably get some tokens from that chain all across to some other random chain that you want and send it back, and you know that your asset, it's going to be safe because all of the connections are secured by cryptography. Magic. Well, I'm going to show you a bit some of the internals to make it a bit more interesting. Right now, we have the application layer, which is what you run on top of the Cosmos SDK. Your application will implement ABCI, which is going to be used to connect to CometBFT. What are all of these? Well, basically, you write your stuff on top of the Cosmos SDK. You use the Cosmos SDK to create your state machine. And then out of the box, you have CometBFT. CometBFT is the consensus algorithm that we have, and it's going to take care of all the peer-to-peer connections. It's going to take care of the transaction broadcasting and all of that. And well, you have your validators and stuff like that there. And then ABCI, sorry, it's the interface that the Cosmos SDK uses to talk with CometBFT. And we say now because we have some stuff coming up, and you'll see in a bit. In a Cosmos SDK app, this is like more into the internals. Like you probably, unless you want, you won't see all of this, because we abstract it, but we don't hide it. So it's not like you won't be able to touch anything. It's just like, if you don't want to touch it, it's fine. You can just leave it there. It's going to do its own thing. But if you want to go there, get your hands dirty and like modify stuff and do crazier stuff, you can for sure, because everything it's out there and you can make use of all of it. So we have the base app, and right now it does a lot of work. So it integrates the CometBFT server, implements the ABCI protocol to talk with Comet. It runs the checks on transactions. So these are, in simpler terms, it would be like a middleware. So basically, you can add a bunch of chain checkers that you can use for do checks on transactions entering your chain. So for example, we use those for fees. So you can check if a transaction has enough fees to pay for the gas. You can do the check for gas. You can do a check for the signature. You can do all of these things and more, because they are chainable. And so they are super useful. Then you have, you have the begin and end blocker in the modules. So each module can define things to run at the beginning and at the end of a block. And then this base app, it's going to take care of running all of that. Then, of course, it's going to execute the transactions. It's going to handle this application-side mempool, and also do the handling of the store. Then we have runtime, which is like a bit up in this hierarchy, let's say, and it's the one that is in charge of creating base app, and it's the one that manages the modules. Let's say it coordinates them. And then finally we have server, and server, it's what starts basically everything. It's like the base of all of this. But the one that is doing all the heavy lifting, in my opinion, is base app, because it does all of this work. And all of this works in a single monolith. Now we are getting into what we call V2. So this is what's coming up. It's super new. It's right now we are working on it actively. And what we realize is that, so we have this mentality of the plug and play. Okay, so we achieve the plug and play at the module level. That's great. But then we realized that there are many users that want to go beyond that. And yeah, they can modify stuff on base app because it's there, they can modify it. But the thing is that they would need to fork the SDK, and while that's okay, it stops the SDK and the rest of the community to get improvements. Let's say, for example, right, like a chain realizes that they can do this improvement on transaction handling, whatever, and they did it on a fork, and maybe it's difficult to get it back on the mainstream Cosmos SDK and stuff like that. So here we went to step even further in this modularity, and we make the entire thing modular. So we have STF, which is the state transition function. We'll do the transaction validation and delivering of blocks. And here we did everything very generic, and generic also in the terms of in the code, because we are using generics in the Go code. So developers can even define how a transaction looks like. They don't have to conform to whatever we have. They can come up with their own transaction. Then we have the app manager, and then so this is like the onion, right? We start going up in the layers, and then we have app manager, and it's gonna wrap the STF and do all the storage and Genesis to get started with the chain. Then we have runtime, this time runtime v2, and it basically does the same as before because it's coordinating all of these pieces. And then here what's interesting is that what we are calling now the consensus engine, we made it also a separate module. So right now, CometBFT, which is what we've been using by default, now it's going to be a module, and then there's like an interface between the consensus module and app manager. So in there you can just swap CometBFT with whatever you come up with. So I don't know, let's say you find a very cool paper and there's like an example implementation of a consensus engine. Well, you can probably just write like a little tiny, well, not very, probably it's not going to be that little, but you're going to write some code and then you can plug it into an existing chain, and it should just work because we are not making any assumptions between those. And then basically after all, we have Server v2, which is going to start all of these things together. Yeah, like I said before, internals are abstracted, but are not hidden. So then you can go there and make your changes and make your own without having to rewrite the whole thing. This is just to show how the internals look, and this is just showing that from B1 and B2, what didn't really change is that before we have base app and all of that right there in the middle, and now we have just runtime and all the modules plug into that. But yeah, you don't have to care. It's just that all of these are the internals of it, and if you just want to build a chain that works and that your module is what contains the actual business logic, then you don't really care about all of this. Then you can probably, I don't know, if you later find out that transactions are not the way you want them to be, well, you can go ahead and start going into that, but you don't have to if you don't need to. So you need to only build modules. That's the most important part here, because here is where you make your chain different from the others. So the modules, as I said before, are the heart of your application. They are a Go module, so we always try to keep to Go for now, because we are thinking about ways of coming up with new modules written in other languages. That's what we are calling cross-lang. So in the future, you could use modules created in Rust, for example, or any other language. And yeah, and so if your module does something that Go as a language doesn't do very well, but probably Rust is very good at, well, maybe you can use Rust just for that part of your application, and that should be totally doable without any complication. So it controls the messages that you can pass in. So every module, it's going to declare its own modules. It's going to say, okay, messages, sorry. It's going to say, okay, these are the messages that I can process, and it's going to expose them to the rest of the app. So then you can use them in transactions, you can use them from other modules and stuff like that. Also, you can add transaction validation, and then, as I said before, you can also allow your module to run stuff at the beginning and end of a block. That would be useful, for example, if you're, I don't know, at the end of the block, you're calculating the median or something. Well, you know that that's going to run right at the end of the block, and there are no more changes to those values after that until the next block. The same goes for the beginning of the block, so you can run stuff before any transaction happens. There's also one here that it's even before all modules that you can run the pre-blocker, and that runs like at the very first place in a block execution. And that's interesting for stuff like both extensions, which are doing calculations with stuff that it's getting from the consensus engine. And of course, you can integrate with other modules. That's something very standard that we use. So let's say you have your staking module, and you want to do stuff with, you have a module that wants to give money to validators or something. So you can actually do a query to this other module to get the list of validators, get the list of their staking power, and all of that. And of course, as always, we need determinism. That's all we need. So let's say, what's deterministic? It's something that with a given set of inputs, it's always going to give you the same answer. What's not deterministic? Let's say an HTTP request. Why not? Because sometimes that endpoint can be down, that endpoint can change the content that it's returning. Many things can go wrong there. What is deterministic would be, if you're calculating a value, you need to make sure you're doing the calculation in a way that it's always giving you the same output, and there's no way that value can change if you run it in another machine, or if you run it at night, or if you run it like in 3 years. Well, that function, that operation must always give you the same result. So yeah, it's very important. Well, some other stuff that the module has, this is more like detail. So we have the interfaces that the modules implement. So we have some interfaces that then the base app or the runtime it's going to use to know if your module has this or that feature. So let's say when runtime wants to run endblocker, it's going to check, hey, does this module have the endblocker function? Okay, no, okay, I'm going to skip to the next one. Does this one has it? Yes. Then it's going to run the end blocker, stuff like that. Then it's going to register the APIs, so the stuff that you can query from other modules, and the functions that also can be called with transactions. Well, Genesis migration. Genesis would be when you start your chain, what are going to be the initial data that you're going to have there. And migrations, because you can never know the final state or what you're going to have in your app, because everything is a business and things in businesses change. So let's say today I don't need to know the price of X thing, but maybe tomorrow I do, or maybe right now I'm storing stuff in one format that is practical today, but maybe tomorrow it's not. And well, we have you covered there because you can run migrations and you can take all data, reprocess it, and you have it in a new format ready to go in a very deterministic manner, because this is going to happen on an upgrade in which all validators are going to do that change. That way you ensure that you're not corrupting your data. Then we have the keeper. The keeper basically has all the storage. You have there, you'll see if you check into any Cosmos SDK app, you'll see this everywhere, because it's, you do accounts.get, keeper.balances.get. You'll see that in many places because it's where the actual interaction with the database is happening. Then you have the message server. So the message server is where the transactions happen. So there you can have, you have a message handler which is going to receive a message that it's going to come from a transaction, and then you can do some checks. You can do some, you can reject that message if you want. You can add, any kind of business logic that you want to add to a transaction. Well, you can add it there. Well, of course, it handles the module messages, and then the querier. The query is basically a wrapper on top of the keeper, and it's gonna make it easier to query for whatever you want to query. So it's gonna be calling the keeper to get data, and maybe you can do some formatting there, or like simplify the way you display it to the user. For queries, this is something that, for example, IBC uses. But for a query, you can mark it as consensus safe, which means that that query is going to be deterministic. Because queries don't necessarily have to be deterministic, but there could be in some places you want them to be fully deterministic, so it always returns the same output. And finally, we have the CLI, which right now it got way simpler than what we used to have. So before you had to write all the CLI handlers for your app, but now we have something that it's called CLI v2 or auto CLI, and it's basically you just define in a very short amount of lines, you define what are the commands that you can run on that module, and then it's going to do all the formatting and like taking the arguments and all of that to convert them to a message. This is just a quick look at how an app looks. And then you have on the left, you're going to see that we can define our app in a YAML. And it's fairly simple because you can define, well, probably you cannot see, but you there in a simple text file, you can define what modules you're going to be using, what are the begin blockers, the end blockers, if there are any specific configurations that modules need to have, well, you can do it there. And also you have a matching app.go, which is going to be the one that loads that YAML file. And here you can even do further modifications to that if you want. And that's it. That's all you need for an app. And I've been saying, oh, it's in the box, it's in the box, it's in the box, and all of that all the time. So what's in the box? Well, you have plenty of things that comes with the Cosmos SDK that are, for example, modules. You're going to have a bunch of these. These are some examples only, right? So you have bank. So it's like, okay, I want my application, my chain, to be able to send and receive tokens. Well, do I have to write that? Well, no, because we got you covered that, and that's bank. And bank, it's going to handle all the sending and receiving of tokens. Then you have staking, which is going to be the one that handles the staking. And then your app now can accept, you can have a token that can be staked, and you can delegate and all of that. Then, well, you have distribution that it's going to pay those validators. You have Gov. And Gov is something really important for the Cosmos Hub, for example, because you can run proposals there, and the token stakers can vote on it and decide the future of the chain. Then you have NFT. So we have a module that is basically built just for NFTs. And of course, we have Mint, so you can have your app mint tokens in any way you want. Then we have some third-party modules that are pretty cool. So you have POA, so proof of authority. So basically, you can have a chain that it's not staking, but you can actually say, oh no, I'm going to build a chain for banks. So I can give one validator to each big bank, and they are going to be authorities. And then you would use a module like that. Then you have Token Factory, so you can create tokens on the fly. You have WasmD, so if you want your chain to be able to run WASM contracts, then you would add that module. And also, well, I just put EVMs because there are many modules that you can use to run an EVM on your chain if you want to do that. Also, some stuff that it comes with signature verification, so you don't have to worry about, you don't have to even think about how the signature of a transaction works and where that gets verified and all of that. We do that for you. The fees of a transaction, that's also handled by anti-handlers. CLI, you have gRPC, you have the HTTP API, and all the peer-to-peer, it's being handled for you. So that's all. Well, it has more stuff, but that's the most important stuff that we include with the SDK. And to get started, well, you can basically go two routes. You can go to check the CMAP on the Cosmos SDK repo. And there we have this huge app that includes like basically all the modules that we include by default. Well, we have them all there. And it's gonna, you can just download it and run it, and you'll have this chain that has bank, that has mint, that has NFT, that has groups, it has lots of things. Or you can use Ignite CLI, which is the one that you're seeing down here. Probably Ignite, it's gonna be better for a hackathon. I know most of you have already started, so maybe you're not gonna change your tool, but maybe for the next hackathon, you can use something like the Cosmos SDK, maybe Ignite, to build your own chain. What is cool about Ignite is that that's actually how it looks. So you just type, create my chain, serve chain, and it's gonna start the chain on your computer. So I think that's pretty cool. And then, well, basically you need to test your blockchain, and this is like most of software. You'll need unit test and all of that. Here would be more specific, so you'll have tests for modules, then integration, end-to-end test, and stuff like that. And finally, you can also test interchain connection with other chains. And then, well, once you build your blockchain, you need to build a front end. You can use the tool that Vlad showed us before, and you can also use these tools. So you can use Cosmos.js, Telescope, and Cosmos Kit to talk with your newly built chain. So thank you so much, and happy hacking. Of course, if you guys have questions, just reach out. Yeah, or you can ask them now, or I'm going to be sitting around here for today and the rest of the weekend.
Questions?
Thank you.
No?